Yes, in this application we're using the Acuity white light CCS Prima with the CL3 MG140 probe, and what we did is we every 10 microns along the x-axis we took a point, and then we would jog it up 10 microns and take another profile across there. So we have, actually scanned a lot of points in here, and what we're trying to show is, as you can see, this is the blue 1 target, and we've laid it over a gauge pin, a steel gauge pin, so that we can get a nice reference to be able to measure the thickness of it. Many of our customers would also use a dual probe approach, where they'd have a probe on either side of this material, and it would be able to give you a very good thickness measurement from both sides. So let's go ahead and take a look at it. As you can see, this material, we're getting very good signal, very good return on it. And let's just take a quick 3D view of this. So here's that material, and let's just optimize the color. And here, once again, you can see that there's the steel gauge pin, and that explains part of that slight curve over this scan. Let's go ahead and let's put in the axis settings. There you go. So you can see that we are taking a 3mm by 3mm scan of this part. And from, of course, looking at it 3D, you can see that we're getting very good results. Shouldn't be any concern about being able to measure this material. And so if we come back to it, let's go ahead and let's go and take a profile across it. And here you can see, as we scan it across there, you can see as an example, here's the steel pin right here, and here's that material. And of course, with a click of a button, we can come in and do a mean average across here, showing that the mean height or depth is about 55.9 microns averaged over that. Also possible to come in here and take a manual measurement where we would, we can see we're getting that height difference of about 59, and here's probably one of the lower points at 51, up to 66, 65. So we can tell that this material has a lot of peaks and valleys in it. So in most cases you would try to average that out. Let's go ahead and look at the next target, and let's just find it real quick. And we'll look at the blue 2 target. And so once again, here's the target. Let's go ahead and of course, here's the ISO 25178, which is the surface roughness, showing that we have about a 23.6 micron surface roughness. So let's take this image and once again, let's go ahead and move that down here to a different page, and we'll expand it. And we'll take a quick look at the 3D view of that. And you can see we got a little artifact here. I don't know if that's frayed on this material or not, but as you can see, we're getting very good height measurement of this material. And of course, if we come back and we want to take that profile anywhere across this, we can select that. We'll put an absolute scale. And of course, with the click of the button, we can make that mean determination here that the mean depth or height's about 47 microns across this area. So just real quickly, we're seeing that we're able to do very good measurements on that. Let's switch and look at the light blue surface. once again, let's go ahead and move this to a separate page. We'll expand it. And we're also getting very good measurement. Let's take a look at it 3D. And you can see that we're seeing that woven pattern of that surface. And to kind of give you an idea of some of the resolution that this probe has. And let's go back and take a profile. And that is, definitely one of the advantages of this CL3 probe. We can measure any surface, any color, and of course you can see we're getting a lot more features on this measurement here. And if we wanted to, we could try to take that quick average. And here we're calculating all the maximum. It says depth, but it's really height. Let's open another suitable, and let's look at the light blue 2. And we're going to take this down and let's zoom that up a little bit. And once again, you can see that we're getting very good results on this. So very good data with the white light confocal, as I would expect that we could. And let's take a look at that profile. Much different features. And you can see once again we're about 192 micron depth, so a little bit bigger. Let's look at the red linen. And we'll take this down. And let's adjust for that color. And let's take a look at it 3D. As you can tell, we're getting very good results on, this. Typically we should be able to measure any kind of fabric. We can really see the woven pattern there. And so what this is really showing is that with, against a reference plane like this pin, or if we had two different probes facing each other making the measurement, we should be able to do it. But of interest, of course, is very important that you do some sort of averaging, because there's quite a bit of difference from peak to valley on these measurements. We can look at here, we're roughly 195 to that peak is 306 microns, so quite a bit of, and here we're down to 35, so quite a bit of features on that. Let's open another one. Let's look at the white linen. And we'll color correct for it. And we'll look at it 3D just to give you an idea of what it looks like. And once again, we're getting very good results. Taking data 10 microns by 10 microns. Profile across there, more in the middle. And we're making those measurements. Give you an idea, between 300, 200, and 200 microns. And let's look at the last white linen here. Let's fit it inside the paper. .3D image. Once again, very good measurements. And we'll move this to the middle to get a So you can see that that the white light confocal is doing a very good job of making these measurements. We should be able to get the thickness and the material definition of this target very easily.